Hello dear students, this is Teach J again, and now let's have our Earth and Life Science class. So today we're going to talk about another topic. Are you excited? Okay, I hope so. So first let me share my PowerPoint. Okay, my dear students, we are now in our week 3, lesson 1, which is the Earth's internal heat. So before anything else, I would like to request to put yourselves in the holy presence of the Lord for our opening prayer and pray your own prayer. So, in the name of the Father, the Son, and the Holy Spirit, Amen. In the name of the Father, the Son, and the Holy Spirit, Amen. My dear students, how are you? I hope you are fine, healthy, and comfortable to where you are now. I think you are ready. So I am going to remind you now our class rules. So remember, in our first meeting, we have the class rules, so it's the same. So let me just remind you that you must be honest, responsible, respectful, polite, and courteous. Okay? Do you follow? So let's get started. Our lesson today is from the most essential learning competency that is described where the Earth's internal heat comes from. So from this, we have these objectives. Number 1, identify where the Earth's internal heat originated. Number 2, illustrate how the internal heat of the Earth originated. And number 3, display perseverance in accomplishing the activities in our lesson. So, to get started, my dear students, I want you to do this introductory activity as a review of our previous lesson. So, in this activity, you're going to identify the terms being described in each statement. That's wrong, that is statement. And then you're going to use the words or terms given below. So these are the terms. Please take note of these terms. These are the disintegration, erosion, metamorphic rocks, sedimentation, and igneous rocks. So in answering, you may pause the video for you to have time to think and write. And for this activity, I will just give you 3 minutes to do. Okay, are you ready? So let's start. Number 1. It refers to the process of breaking massive rocks into small particles. Yes, the answer is disintegration. Very good. Number 2. A geologic process of removing the earth materials from their original location to a new site. Okay, nice one, my dear students. That is erosion. Next, number 3. A type of rock which is formed when pre-existing rocks are subjected and directed to heat and pressure. What is this? If your answer is metamorphic rock, then you are right. Very good. Next, it refers to the tendency of particles to settle in a liquid. Yes, the answer is sedimentation. Nice one. The next one is a type of rock which is formed when magma cools and hardens. Yes, the answer is igneous rock. Okay, my dear students, do you get perfect? Good job, my dear students. You really recalled our previous lesson. So this time, I want you to do another activity. So in this activity, you're going to label the given illustration. So again, you can choose your answer from the words below. So take note of these words. Asthenosphere, lithosphere, mantle, outer core, crust, and inner core. So take note. Are you done? So let's get started. By the way, you may write your answer in any sheet of paper you may have there. Okay. Now start labeling. Okay, let's check. Yes, number 1 is the crust, and the number 2 is the mantle, number 3 is the outer core, number 4 is the inner core, and number 5 is lithosphere, and number 6 is asthenosphere. So look at the parts of the earth. I think you are familiar already with this one. I think this is just a review for you. Okay. Again, do you get perfect? I'm happy for you if you got it. Nice one, my dear students. So keep up the perfect score. I hope you will do the same to the next activity until we finished. Okay, let's move on. How do you find the activity? Yes, it is easy and fun because it is just a review. Number 2, how did you identify the parts of the earth? Okay, very good. It is based on what you have already learned from your elementary years to junior high school years. So if you apply those basic knowledge, then it is easy for you to identify, right? Okay, how about this? Why do you think you have to know those parts of the earth? Yes, it is important for us to know those parts of the earth because we will use those terms or words in our lesson. So let's have our discussion. Where do you think Earth's internal heat originated? Do you know? Okay, first thing, we must know the processes on how heat is being transferred. So Earth's internal heat is transferred through the following processes. So these are the three processes: the conduction, convection, and radiation. And do you know what are the differences among these three? Okay, let us know this one. First, what is conduction? Any idea about this? Okay, heat is being transferred through rapid collisions of atoms, which can only happen if the material is solid. Take note, material is solid. Heat flows from warmer to cooler places until all are in the same temperature. It is very common that if there is one thing that is very hot and then you're going to put something cool to that warmer or hotter object, then the cooler one will become also hot. That is why we can say that the heat flows or being transferred. So that is how conduction happens. So in addition, the thermal energy of the core of the earth is transferred to the surface of the earth and lower levels of the oceans through this process. So it's the same thing of our earth's internal. Okay, the mantle is hot mostly because of heat conducted from the core So if you could still remember from your activity that the core is the innermost part of the earth, followed by the mantle. So if the core is very hot, then the mantle will become hot also because of the conduction process. So due to the high temperature, the mantle behaves as a viscous fluid. What is viscous fluid, my dear students? It is a thick fluid. Okay? So let us illustrate in our uh, daily life. Uh, do you experience boiling water in a pot? I think this is very common. So why do you think I set this one as the example for conduction? Where do you think conduction happens here? Okay. If you noticed with this line, it is pointed to the handle of the pot. So if you notice the color, it becomes red because as the body of the pot becomes hot, the heat is being transferred to the handle because the handle is being attached to the body of the pot, so there is a direct contact. So that's how conduction happens. So the heat from the body of the pot is being transferred to the handle. So that is why if you're going to hold or touch the handle of the pot, it is really hot. Okay? Do you understand? So that is conduction happens. So in our earth, this is how it is happening. So this is the inner, which is the core. It's the yellow one, and then the brown one is the mantle, which behaves as a viscous fluid. If you notice, if the inner core is very hot, and then this mantle part of the earth is attached to the core, so there is conduction really happens. So because the mantle part of the earth has a direct contact with the core, so the heat from the core part of the earth is being transferred to the mantle. Okay, my dear students, do you get it? So that is how the internal heat of the earth is being transferred. So let's proceed. Now, let us unlock what is convection. So, convection refers to the process where matters or particles rise or sink due to the difference in temperature. So, take note of the underlined words, rise or sink due to the difference in temperature. This occurs when liquid or gas are heated unevenly. So, this usually happens in liquid or gas. Or this usually occurs in the bodies of water and in the atmosphere. If a material is able to move, even if it moves very slowly, my dear students, convection currents can form. Okay? So convection in the mantle is the same as the convection in a pot of water on a stove. So if you could still imagine the picture or the illustration that I have shown in the previous slides. Okay, but don't worry, I will show it the next slides. Convection currents within Earth's mantle form as materials near the core heat up. So, as I have told you, since the innermost part, which is the core, is very hot, then the heat is being transferred to the mantle, which happens that the materials there near the core heat up also. So, as the core heats the materials at the bottom of the mantle, their particles will move more rapidly, decreasing its density and causing these materials to rise. So, if you notice, if the materials kuno nga doon sa core, ma-heat up na siya, sumugaan na siya, and then that's the reason nga mo rise up ang particles. Okay, do you follow? So, this is the illustration again. So, where is the convection here? So this is the convection. Follow the arrow. If you notice, inside the pot there is water boiling and there are arrows there. So if you notice, if mag-boil ta og tubig, mag-form siya og bubbles. So from liquid to gas. So kaning mga red na bubbles here, these are the hot particles which will rise. You notice the arrow is going up. And then reaching above, the temperature changes. So the temperature decreases. As you notice, the bubbles here are white. So they spread horizontally, move horizontally. And then afterwards, they sink down. Okay, they sink. And then they will be heated again and become, no. It will be heated again because of this bottom part of the pot, which is really hot. So this will become again red color and then goes up again. So that is how convection happens. The heat is being transferred due to the molecular motion in gas or in liquid. Do you understand? Okay. So the rising materials begin the convection current. So in the example, as the bubbles in our boiling water becomes hot, it rises. So, ana na magsugod ang convection current. So, when the warm materials reaches the surface, so katong mga bubbles na hot kaayo or the particles na hot kaayo, maabot na sa babaw, they spread horizontally. That's what I have explained already. The materials cool because they are no longer near the core. So, ang core ato is the fire or the fire from the stove, right? So it eventually become cool and dense enough to sink back down into the mantle. So, ingabot to sa babaw, katong bubbles, mabugnaw to siya, and then mabugat na sa balik, sumuo na siya, musink na sa siya. So, that's the process. At the bottom of the mantle, the materials travel horizontally and is heated by the core again. So, katong mga nabugnaw na, mubalik na sa to, muna if you notice, if pabukal tag tubig, magkuan-kuan na siya, muna siya mag-ana siya. Okay? Do you picture it out? Okay. So, if we're going to look for our Earth's internal, this is what happened. So, this is the mantle which is near to the core or being next to the core. So, it is very hot here. That is why the particles goes up and then spread horizontally like this here. And then as it goes up, the temperature changes, it cools down, so it will become dense again, so it will sink. So, mubalik na sa siya diri sa part sa mantle na doon sa core. So, mubalik na sa siya ka init, and then it goes up na sa siya. So, as it repeats, so the convection current form. Okay, that is how the convection happens. This is a simpler illustration. Okay, up and then down. Okay, I hope you do picture it out and understand. So they reach the location where warm mantle materials rise and the mantle convection cell is complete. This results to the movement of plates. So, mao din hinungdan nga naatay nahibalaan nga movement of plates, if you could still remember in your science 10. So, convection moves hot materials upward at divergent plate boundaries and moves cold materials downward at subduction zones. So this time, let's talk about radiation. What is radiation? So radiation is another form of heat transfer. It is the least important when it comes to heat transfer within the Earth. Dili kuno ay siya importante compared to the first two. So it does not require any medium and can be used for transfer of heat in a vacuum as well. So that is radiation. So let us have an Illustration later. This method uses electromagnetic waves which transfer heat from one place to another. So again, electromagnetic waves. The heat and the light from the sun in our solar system reach our planet using radiation only. Inside the Earth, radiation is significant only in the hottest parts of the core and in the lower mantle. So if you imagine, adto ra siya mag-focus sa pinakainit nga part sa core and then the lower part which is next to the core sa mantle. Okay? So let's have the illustration. If you notice, there are arrows which are red. What are they? What are they? So these are the heat energy coming from the fire that goes up through, or that radiated. So that's how the heat is being transferred. So from the heat of the fire, there are rays there nga musaka siya. That is why bisag ang pot wala siya na-touch sa fire, mainit gihapon ni siya. Matransfer gihapon ang heat. It's because of the radiation. Okay? Do you understand? The heat is being transferred in the form of rays or waves or particles. So, that's why if you notice, if there is fire and then magpaduol ka niya, maka-feel ka nga, manginit sad ka, it's because of the radiation. Okay? That is a simple application in our real life so that we can picture out our Earth. So, talking about it, so this is the core of our Earth, followed by the mantle, and then this is the crust. So, how is radiation happening here? So, from the sun rays, the heat is being absorbed by the ground. That is why natay di ingon nga radiation kay ang heat sa sun mo radiate na siya padung sa ground sa atong earth, sa atong surface, and then padung na sa lalom, and so katong nga heat na transfer na siya sa earth. Okay? Pero from the definition itself, ang pinakainit dire nga core sa earth, maka-form na siya og radiation ari ra dapit sa lower part of the mantle which is next to the core. Okay? In 3D picture, this is how it happens. So from the innermost part of the earth, look at the radiation or the electromagnetic waves. So that is how the heat is being transferred. Okay, my dear students, so those are the 3 processes of heat transfer. So this time, let us know what are these parts of the earth. Okay, let's unlock the terms that we had in our activity. So first, we have the crust, which is the outermost layer of the earth. It ranges from 5 to 40 kilometers. It is classified into 2, the continental crust and the oceanic crust. So, kani siya. Kani atong gitumban, this is what crust looks like. Ang mga tubig na part is the oceanic crust. And then the next part of it is the upper mantle. It extends from the Earth's crust to a depth of 400 kilometers. This part is composed of solid and malleable materials. This part plays a great role in tectonic activity. This is also where you can find the asthenosphere. So if you notice the labeling, this is the upper of the mantle, and we have here the lower in another color. Okay, again, upper mantle, this is where asthenosphere located. It is a hot, malleable, and fluid-like layer in the upper mantle. Okay, whereas in lower mantle, it is a liquid portion of the mantle. This part is hotter and denser compared to the upper mantle. This part is made of silicon and magnesium. So, this is a liquid portion of the mantle, and this part is, it's not liquid portion because it is just the extended portion from the crust. So the innermost part of the earth is the core, which is composed of two, the outer and the inner. So what's the difference? Outer core made up of superheated metals, iron and nickel. Magnetic fields are created in this layer. So kani siya nga color, it's gray scale manggod siya, so dili siya maklaro. So inner core, the innermost part of the earth, is composed of iron and nickel. Against same, due to high pressure, the materials remain solid. So kani jud ay nga part maoy solid. The temperature in this layer is too high compared to the other layers. So if we compare this many layers here of the earth, the inner core is the solid one and with the highest temperature among all. Okay? So lithosphere comprises the crust and the upper mantle. So if you notice the labeling, so that's the lithosphere. Upper, mantle, and crust. And asthenosphere is next to the lithosphere, wherein also found in the upper mantle. Okay, do you get it? So let's proceed. Now, from our discussion the previous slides, in what layer of the earth does convection current take place? What do you think? Okay, very good. It takes place in the mantle. Earth's internal heat is also known as geothermal heat. Again, Earth's internal heat is also known as geothermal heat. This is responsible for various geologic events. So what are these geologic events? Let us discover it later. So internal heat originates from the following sources. We have three: the radiogenic heat, primordial heat, and the frictional heat. So let's differentiate the three. So radiogenic heat, radioactive elements such as thorium, uranium, and potassium split up and give off nuclear radiation. So what do you mean by split up? Magpulag na siya. And that's the time nga mahatag na siya of nuclear radiation. This releases energy that would eventually heat up the surrounding particles. The kind of heat produced from this activity is called the radiogenic heat. Okay? That is from the radioactive elements na mo split up na makahatag og nuclear radiation. That is how makapainit siya sa mga particles that surrounds. Okay. Next, primordial heat. From 4.5 billion years ago, the Earth was formed from clouds of hot gases and particles. Okay, take note, clouds of hot gases and particles. So, the primordial heat leftover from this formation is seen to be one of the sources of the Earth's internal heat. Okay. Itong mga residual, mga nahabilin na formation of clouds of hot gases and particles daw, it's also one of the source of the Earth's internal heat. Okay? So, internal heat drives the following geologic events. So, mao ni siya nahitabo tungod sa kainit sa sulod sa Earth or the internal part. Number 1, movement of plate tectonics. The internal heat causes thermal convection which drives movement of plate tectonic. If you notice from the convection current, the rising and sinking of the particles or the materials that causes the movement of plate tectonics. So number 2, formation of volcanoes, mountain ranges, and ridges. So if you notice, nakadaghan ang mountains na to, that's because of the internal heat. Occurrence of earthquakes, of course, it's very common because we experience this one. And then formation of igneous and metamorphic rocks because we have this internal heat of our Earth. So these are the geologic events. Okay, students, are you still following? Earth's internal heat is transferred through convection, conduction, and radiation. Do not forget that. That's the first one that I have discussed. So the Convection current is the repeated cycle of sinking and rising of materials beneath the Earth's surface. The hot, molten rocks rise up to the Earth's crust, and when these materials lose heat, they sink back down to the core until they get heated again. So that is the cycle of the convection current. So if you still remember, the arrows there is going up, down, going up, down. Okay, that's convection current. Okay, the illustration of our convection current will not show. I'm sorry for that. Okay, this one. This is from the illustration in your module. So if you notice, this is the convection current in the mantle. So if the material is heated, it goes up and then it moves horizontally and it sinks in the subduction zone. Okay, here. Okay, this is the continental crust where we are now. Okay, and this is the oceanic crust, the water part. Okay. The heat of Earth's interior comes from a variety of sources. These include the heat contained in the objects that accreted to form Earth and the heat produced when they collided. As Earth grew larger, the increased pressure on Earth's interior caused it to compress and heat up. Heat also came from friction, when melted material was redistributed within Earth, forming the core and the mantle. So this is the third source of heat in Earth's interior. Okay, friction. Okay, again, my dear students, the internal heat is released at the Earth's surface, forming a new crust. Okay? Do you have questions? Clarifications? Okay, again, there are three processes of heat transfer. We have conduction, convection, and radiation. Then, what are the sources of Earth's internal heat? We have the radiogenic heat, the primordial heat, and the frictional heat. Okay? So, you also know the geologic events caused by the Earth's internal heat. Okay, for example, the formation of mountains, volcanoes, the occurrence of earthquakes, movements of plate tectonics, and occurrence of the earthquakes. Okay, those are some of the geologic events caused by the Earth's internal heat. Okay, am I clear? So let's proceed. Okay, this time, let's have an application. So in this activity, again, we pause the video for you to answer, for you to have enough time. Okay, in this activity, I will just give you 5 minutes will do, or if you need more time, it can be 10 minutes. So you are going to complete the diagram with the correct term or phrase accordingly. So, again, you may use a sheet of paper there, whatever you have, and then do this. Are you ready? Let's start. Okay, complete the diagram. Okay, let us check now, my dear students. Be honest. Okay, the Earth's internal heat comes from, again, radiogenic heat, primordial heat, and then frictional heating. Okay, which drives the following geologic activity. So you have formation of mountains, ranges and ridges, formation of igneous rocks, movement of plate tectonic, formation of metamorphic rocks, formation of volcanoes, and occurrence of earthquakes. So these are the 6 geologic activity that happen due to the Earth's internal heat. And how this heat being transferred? This is through conduction, convection, and radiation. All in all, my dear students, you have how many? 12. So, your score will be 12 over 12. So, do you get perfect? Okay, very good. Keep up the good work. So you really listen to the discussion. Very good. You are very attentive. So now let us assess. Let's have the assessment. So again, you may use another sheet of paper or continue with what you have used in the previous activity. Read each question carefully and then write the letter of the correct answer. Okay, ready? Let's get started. Number 1. During convection, hot substances blank while colder substances blank. A. Rise, sink. B. Sink, remain stationary. And then C. Rise and remain stationary. And letter D. Sink, rise. Number 2. In which region of the earth is conduction the dominant heat transfer mechanism? A. Crust. B. Mantle. C. Inner core. D. Outer core. Number 3. Which of the following is or are the source or sources of Earth's internal heat? A. Residual heat from when the Earth was formed. B. Frictional heat from the movement of materials in a mantle. C. Radiogenic heat from the decaying radioactive isotopes. Or both A and B. Number 4. How does radioactivity contribute to the production of the Earth's internal heat? Is it A. The movement of materials in the mantle produces heat? Or B. The energy and the energetic particles heats up the surroundings and the particles around them that leads to the production of heat? Or letter C. The heat from the internal core was absorbed by the radioactive elements and is released during the radioactive decay? Or letter D. All of this. Number 5. Which of the following statement is true? Is it A. As we go deeper beneath the Earth's surface, the pressure and the temperature increases? Letter B. There is an increase in pressure but decrease in temperature when we go deep down the Earth. Letter C. There is a decrease in temperature and pressure deep beneath the Earth's surface. Or letter D. All of this. Okay. Check your own paper again. So these are the answers. So, how was it? How was it? What's your score? Okay, congratulations, you did well. Yay. Perfect. Okay. So, you really have it. You really know now where the Earth's internal heat originated. So this time, let's have an enrichment activity. Okay, using your cell phones, make a video of yourself demonstrating a certain heat transfer at home. Okay, afterwards, say something about it that is related to Earth's internal heat. That means you're going to integrate your demonstration with something to the Earth's internal heat, my dear students. And then you may edit it or send it directly to me. Okay, send it to me with in my messenger account or to the GC. Okay, but if you don't have the gadget or signal to do so, make your own way of demonstrating the heat transfer. It's up to you. It's your own resourcefulness and creativity. I will look forward to the output. Okay? So, reminders for safety precautions. Of course, since you are going to demonstrate the heat transfer, it is very dangerous. You have to be careful in handling everything. And then, of course, you should at least have an adult to look for you. And be careful always. Okay? Any questions or clarifications? None? Okay. So that's it for today, my dear students. Stay safe And then always practice the healthy lifestyle, especially during this time of pandemic, because we need to be healthy, uh, mentally, physically, emotionally, and holistically, of course. So, stay safe, God bless, and good luck with the activity, my dear students. Thank you very much, and God bless. Bye. See you next lesson.